Hello students, lesson number 3rd, triangles. Under this lesson, we will see the next part of our lesson, and I gave you an activity to understand the side angle which is greater angle which is opposite to the greater side of a triangle. So that activity we had done, and now we will see it's a proof. So we took this activity and I told you to draw any triangle and you have to check measures of all angles of a triangle. So which angle is greater angle? This angle which is opposite to the greater side. So in this triangle xy is a greater side and its opposite angle is a y angle, and if you observe or if you measure the angles, you will notice that sorry yz is greater side, yz is greater side, and if you measure the angles you will notice that this x angle is greater one, and the smaller is the xy, and the smaller angle is z angle because it is opposite to the smaller side. So first of all, if we will see its proof now. If two sides of a triangle are unequal, okay, equilateral triangles are there, as you know that the all angles are same, that is 60 degree only. Okay, so here if two sides of triangles are unequal, then the angle opposite to the greater side. So here it is triangle xyz. Okay, if you see in this triangle, you will notice that all sides having different measures. Okay, and xy, yz and xz, these all sides measure is different. If such a triangle is there, okay, then what is the our theorem? Then the angle opposite to the greater side, so here which is greater side, that is xy is a xz is a greater side, is greater than the angle opposite to the smaller side. Okay, so smaller side is the xy. Regarding to any angle we can take this. Okay, so here we have to given inside what we have to write in triangle xyz. Here it is triangle xyz. Which side is greater? They are comparing these two sides, that is xz and yx. If you compare these two sides, you will notice that which side is greater is here, that is xz is greater, xz is greater than xy. Okay, so what we have to prove? That angle y is greater than angle z, angle y is greater than angle z, that we have to prove. Okay, so here it is given y, and we can read it in three letters also. So x y z, and another angle is is smaller than is greater than angle x z y. And to prove this, what we have to do? We have to construct one triangle only. How much measure is the xy? Same measure we have to take on xz. Okay, so xy is equal to xp, and here we have to draw this triangle. Okay, that is our construction. Take point P on xz such that xy is equal to xp. How much measure is the xy? Same measures xp we have to take, and we have to join this y and xyp. Okay, now here it is triangle xyp. Now in triangle xyp, if you see here, that is two sides are equal, that's why it is a which triangle? That is isosceles triangle, right? So if isosceles triangles are there, its base angles are congruent to each other, that we know. So here written xy is equal to xp there, and angle xyp is congruent to angle xpy, because this is the isosceles triangle. Okay, now if this angle xpy, this xpy is greater angle, okay, exterior angle of triangle pyz. Okay, suppose this is our triangle, I will give it different color. I shown with blue color. This triangle is there, and this triangle's exterior angle is this. Which one? xpy. xp y is exterior angle. This xpy is exterior angle of triangle ypz. Okay, and as we know that the exterior angle xpy is greater than pzy, because these angles measure of a x p y is equals to p z y, means this angle plus this angle. Okay, sum of p y z and p z y, angle p y z plus angle p z y is equals to angle x p y. Okay, so these two angles sum is equal to this angle. So this angle is there, that is xpy is greater than pzy also and pyz also. Okay, so that is written here, xpy is greater than pzy. Okay, xpy is greater than pzy because of exterior angle theorem. Now xpy is greater than pzy, and this xpy is congruent to xyp, this xyp. Okay, then from this we can say that this angle is greater than this, and these two angles are congruent to each other, this and that, and that's why this angle xyp is greater than pzy. In that way we can prove this. Okay, now next what they told, so it is measure xyp is greater than pzy. One angle we have to add in this. Which angle we have to do this? So now we prove that this xyp means which angle? This xyp is greater than pzy. Okay, is greater than pzy. And if we add this angle, means pyz in xyp. Okay, already xyp is greater than pzy. Okay, and if I add one more angle inside it, then it is also greater than, means xyz is greater than pzy. Okay, and instead of reading pzy you can read xyz, then you will get your required proof. So again I am explain to you, if this is an isosceles triangle, which that angle triangle xpy, if it is isosceles triangle, these two sides are congruent and their base angles are also congruent to each other. So these are the base angles, that is xyp and xpy. These are the base angles and they are congruent to each other. And if you think about related to the pyz triangle, so xpy means this angle is there, xpy is greater than is exterior angle for the triangle pyz. Okay, and if it is exterior angle, its measure is equal to, is greater than this pzy also and pyz also, because sum of these two triangles, that is pyz and pzy, these two sum is equals to xpy according to exterior angles theorem. Okay, so if it is greater than this both is equal to sum of these angles, then xpy is greater than pzy. Okay, xp y is greater than pzy. Okay, but this xpy is there, it is congruent to which angle? xyp, angle xyp, because these are the base angles of the isosceles triangle. It is also greater than angle pzy. Okay, next step is that in this angle inside xyp, inside you just add the pyz. So here write angle xyp plus angle pyz is greater than angle pzy. Okay, and instead of reading the p, you can read this angle from x, you will get your required proof. Okay, and sum of these two angle is equals to how much? xyp plus pyz is equals to angle xyz is greater than x angle xzy. Okay, so in this way we can prove that the angle which is greater that which is located in front of the greater side. In that way we can prove that this theorem. It is a very short theorem actually. All of you note down. Now here it is the next activity is there. What is the activity? Two angles of a triangles are unequal. It's a what we are saying, converse is there, the above theorem is there, its converse is here, and the converse, see here, same properties of inequalities of a sides and angle of a triangle, its converse is here. If two angles of a triangle are unequal, okay, means B is greater than C, then the side opposite to greater angle means its opposite side. B is greater angle, B is a greater angle, its opposite angle side is the AC. AC is greater than the smaller side opposite to smaller side. So C is the smaller angle and its opposite angle side is the AB. So AC is greater than AB, that we have to prove. And this is the activity. So given inside, this is the triangle ABC and angle B is greater than angle C. Here it is written. And we have to prove that AC is greater than AB. AC is greater than AB. Now we will see it's a proof. There are only three possibilities. Okay, which three possibilities are there? This AC is there, it is greater than AB. So which is the second possibility? That is AC is smaller than, sorry, already written here, smaller than. So first possibility is the regarding to length. There are three possibilities. So first possibility is AC is there, this AC is greater than AB. Okay, so I will write here AC is greater than AB. Second, AC is smaller than AB, that is already written here, AC is smaller than AB. And the third possibility is the both are equal, AC is equal to AB. Okay, AC is equal to AB. So here these possibilities are there. So here first possibility, that is AC is smaller than AB, is given. And how is its proof, that we will see. All of you note down this. Understood what I said? Regarding to AB and AC, there are three possibilities. Maybe this AB and AC is same. Maybe AC is greater than AB, or maybe AC is smaller than AB. Okay, so these possibilities are there. Now one by one we will study these properties. Let us assume that first possibility, that is AC is smaller than AB. AC is there, this AC is there, it is smaller than AB. So what is its this possibility if we are taking? If two sides of a triangle are unequal, then the angle opposite to greater side is greater. That now we seen. That we had seen. What they told you? Above theorem is there. Just now we seen that theorem inside. The angle which is opposite to the greater side is greater. So angle C is greater than angle B, right? But in given inside, what is given? C is greater. C is smaller than B. C is smaller than B. And here from our statement, what we prove that C is greater than B. So this creates a contradiction, and therefore AC is smaller than AB. Means first possibility is wrong. First possibility is wrong. Understand what I said? That if I will draw here triangle for understanding. This is our triangle. This is triangle A, B, C. Okay, so in this triangle ABC inside, what the side angle here, our statement just now we prove that if sides of a triangle are unequal, then the angle which is opposite to the greater side is greater one. So here B angle is greater, already given here. So if B is greater than and we are saying from our here statement, that is AC is smaller than AB, means AB is greater, then angle, its opposite angle C is greater than angle B. Okay, but given inside, given C is smaller than angle B, and these two statements are contradicts, and that's why AC is smaller than AB is wrong. Okay, now after this we will move towards this third one. Second, here second given means here Second inside it may be AC is equals to AB. Okay, so AC is equal to AB is there, then it is isosceles triangle, and isosceles triangles base angles are congruent to each other. So angle B and C are equal, but we here given inside given angle B is greater than angle C. Angle B is greater than angle C, and therefore this also contradicts the what? Contradicts the given, and that's why what happens, the our statement that AC is equal to AB is also wrong. AC is equal to AB is also wrong. So only one possibility remain, and which is that one possibility? The possibility is that AC is greater than AB. So that is the third possibility left. It is also a very easy activity is there. So you have to complete this both the theorems today. Next, here this is the let's recall question is there, and here what they shown you, I shown in the adjacent figure, means in this figure inside there is a shop A. This is shop A, and here it is C. It is the Samir was standing here. To reach the shop, the way C to A, it is the direct way, and the another way is there, C to B and B to A. So this way is there. So from this, what is our what is given here? Because B to A, because he knew that C and A was shorter than the way CBA, means AC is shorter than CBA. Okay, as we know that, and that we seen also, its recalls activity is there. So which property of triangle had realized here? That is Pythagoras theorem is there. Okay, sum of the two sides of a triangle is greater than its third side, means AB plus AC BC is greater than AC, means sum of two sides of a triangle is always greater than the third side. Okay, so if you take BC's measure is smaller than AB plus AC, AB's measure is smaller than BC plus AC. So let us prove this property. To prove this property, here one more theorem is given. The sum of any two sides of a triangle is greater than the third side. So here ABC is a triangle, and we have to prove that any two sides sum is there, it is greater than the third one. So here given inside what will come, ABC is a triangle, and to prove inside what will come, AB plus AC is greater than BC. Okay, next this one, first one I will show. Second, AB plus BC is greater than AC. So AB plus BC, this measure is also greater than AC. And third, that is AB plus BC, this AB plus BC is also greater than, AB plus BC plus AC is greater than AB. These three are there that we have to prove. So for that what we have to do? So first of all we have to take a point D. Okay, we have to take point D in such a way that it locates on ray BA. It locates on ray BA, and its measure is exactly equal to AC and AD. These two measures are same. AC's measure and the AD's measure is same. Now here in triangle ACD, which triangle? ACD. In this triangle ACD inside, if these two sides are congruent to each other, the given triangle is a isosceles triangle, right? Now AC is equal to AD, and it is our construction. Therefore angle ACD and ADB, these two angles are congruent. It may you can use the what we are saying, isosceles. Here CACT don't know. Here we want ACD and ADC. So here we want which? That is the isosceles triangles property. Now in this ACD inside, these angles are congruent. If we add ACD in this triangle inside, if we add ACB, this angle we have added, means we done the addition of this both. Okay, then is greater than ADC. This angle is there, whole angle is there, it is greater than this angle ADC. Okay, these two are the congruent angles, and if inside it I will add any angle, it may be 1 degree angle, then also this angle, that is ADCB is greater than ADC. Okay, DCB is greater than ADB. Now what we shown that these two angles are congruent to each other, and if we add this angle inside it, okay, which ACB angle if we add inside it, then angle DCB is greater than ADB. Okay, now if this angle is greater, which angle? BCD is greater, then BD is greater than its angle D's opposite side is the BC. BD is greater than BC. Yes, BD is greater than BC. Okay, BD is greater than BC. Now what we have to do here, BD means what? BD means BD means is the sum of AB and AD. So here AB plus AD is greater than BC. Okay, now if AD is congruent to BC because they are what? Isosceles triangle or our construction. So I will replace here AB plus AD, I will replace with the AC. AC is greater than BC. In that way we can show that the sum. Now if you see here AB and AC, these are the two sides of a triangle. Okay, so AB plus AC is greater than BC means sum of two sides is always greater than third side of a triangle, and that theorem we prove now. Okay, so one more time I will revise it. What we have to do, we have to do the construction. What is our construction? We have to take a point D on AB such a way that the AB is equals to AD is equal to AC. Now because of this is the isosceles triangle and these are the base angles, they are congruent to each other. Okay, now you have to, after that you have to add in ACD inside, you have to add this angle ABC. Now this angle is greater than this angle because we add the one angle inside it. Now if you see, this is the greater angle, so BD is greater than D's opposite side BC. Okay, BD is greater than BC. BD is greater than BC, and BD means what? AB plus AD is greater than BC, and AD you have to replace with the AC. So here AB plus AC is greater than BC, and that is our what? Proof, that is sum of two sides of a triangle is greater than third side. In that way we can prove that. These three theorems are very easy, and after that you have to solve the 3.4 exercise today. Okay, and then we will take the next points next period. That is, and you have any difficulties regarding to this, you can ask me anytime. Okay, so today we will stop here only. All of you do the practice of these three theorems. Okay, thank you and have a good day.